Chapter 21 Physics Theory Video 3. We are going to the last lesson of this chapter, force on a charge. So now we got two equations, E equals F upon Q and E equals negative V upon D. So then we can combine these two general equations, that is FQ and negative V upon D, and we can obtain an equation F equals QE equals negative QV upon D. That is, instead of E we put negative V upon D. Then if there is an electron with charge E, then Q becomes negative E, then it becomes positive EV upon D, right? So the force created by an electron is EV upon D. So then a beam of electrons, if it enters a space between two charged parallel plates, how the beam is going to move is what we are going to figure out using these two equations. So now you know that in the Van de Graaff generator, it creates enough charge so that a spark can move from one point to another through air, just like lightning does. Now, if we think about the force on a single electron, like shown in here, the upper plate is negative and the lower one is positive or less negative. So the electron is pushed downwards because it is attracted towards positive, right? So the negatively charged electron is being attracted by the positive plate, and negative plate repulses. There is a repulsion there. So when it repels, when the negative field when this negative field repels, the top negative field repels it, the electron will bend downwards. When the positive one attracts it, obviously again it gets bent downwards. So it travels in a curved path, right? So this curve is a parabola, obviously, like that you have the parabolas that you have drawn when you were doing maths in O levels. If the electron was stationary, then what would happen? It would directly come down. But here, because it is not stationary, it goes in this parallel. Because it is traveling between these plates, it travels in a parabola. So then we have to figure out what these charges are and what kind of a force is acting on it. Because in each point the same force acts on it. In each point in this field, the same force acts on it, and it is being pulled down in the same way. Just like when you throw a ball in the gravitational field, the gravitational field is the same throughout. As a result, the ball will travel in a parabola, right? So that is exactly what happens here. When the electric field lines, where field strength is the same overall, the electron would be attracted in the same manner. But if it is dropped, rather than throwing, if the ball is dropped, then it would directly fall, right? So that is what we have understood so far, and that is exactly what we need to use in these calculations. Write down the note: force on a charge. The force F on a charge Q in a uniform field between two parallel plates can be calculated by combining the two equations for field strength. Within brackets, E equals F upon Q and E equals negative V upon D. This gives us F equals QE equals negative QV upon D. the first equation here. F equals QE equals negative QV upon D. Then leave a line and write, if a single electron is considered as it would have a negative E charge, the equation becomes F equals simple EV upon D so that means the charge of the electron multiplied by the voltage divided by the separation. In below example, when a beam of electrons travel between two electrically charged plates, electrons would start traveling in a parabola. I hope you can remember the centripetal force. Just like that, it goes in a circular trajectory because of the force, that is uniform force that is attracting it towards the center of this particular circle. They would start going in a traveling in a parabola because the electrons are attracted towards the positive plate. However, if the electron was stationary, it would be directly accelerated downwards. Please draw 21.14. Pause the video and draw 21.14. After drawing, please write this down. This force on electron is quite similar. The force on electron by the electric field is quite similar to the gravitational field, to the gravitational field that would act on a ball being thrown horizontally or dropped. When it is thrown horizontally, it will travel in a curved trajectory, just like the electron, because gravitational field strength is also uniform. Right, I hope you understood everything. Then please do from question 9 to 12, and after you are done with it, please do the endo chapters. So there are many equations that we learned here. So the most important ones are E equals F upon Q and E equals negative delta V upon delta D. So then if it is a uniform field, the force on the charge is going to be on the same, and then we can get negative delta V upon delta X is the separation once again. Then an electric charge, if it moves at right angles to the field lines, would take a parabolic path. Please go through the videos and the notes that you have written once again, and if you are comfortable with everything, please do the endo chapters, and after you are done with them, if you have any questions or doubts, please raise them, then I will explain it further.